Hi, good afternoon. My name is Tijani Adebowale and I'll be presenting the soft design for Scarborough gas field development proposal as presented by my group with the name of Ibikun Ibitoye, Ms. Gloria, and Mr. Mustafa. First off, I'd like to describe the location of the gas field. Scarborough gas field is located approximately 375 kilometers off the peninsula in Carvanon Basin around Western Australia. And the partners to this project would be in collaboration with Woodside Petroleum and BHP Billiton. Woodside is holding currently 75% interest and operating the field. For the project, we'll be talking about I'll be talking about the concept selection for the subsea system to produce the gas from Scarborough field. Thereby, I'll be talking about the setting production rates to optimize return on investment, high-level system definition and determining an optimized subsea structure and justifying equipment sizing and field life. I'll also be talking about the design equipment and provide an operating philosophy to permit production to the field, and also the development of an environmental risk assessment management plan. Concept selection. Basically, the floating liquefied natural gas, FLNG, would be a preferable consideration in terms of minimizing the subsea pipelines where consolidating processing and liquefaction would be considered, alongside the storage from offshore and also offering a cost-effective situation in remote areas. In terms of semi-submersible to onshore Pluto LNG, would be including an in-field processing for the gas dehydration and compression, offering potential for expansion with onshore facilities. The expansion and integration requires very high capital expenditure and also downtime on existing operations. For subsea tiebacks to the new onshore LNG, the subsea development option with potential for floating and or subsea compressions, similar to environmental impact to the Pluto approach, would involve complex and risky management of fluids in. Now, the specification for the processing facility. First of all, we'll be looking into the gas compression unit. For the gas compression unit, it will be required to handle the initial reservoir pressure of 2,820 psi. That's approximately 194.4 bars of pressure, and also to ensure that the flow is sufficient to the FLNG platform. We'll be moving on to the next unit, which is the dehydration unit. The dehydration unit is meant for the removal of residual water vapor and prevent hydrate formation. Then we move on to the gas treatment unit. Though it is minimal, the CO2 and the nitrogen removal unit will be installed to meet the LNG specification. Then the liquefaction trains would be designed to convert the dry gas into LNG at an optimal efficiency level. Finally, the export pipeline system, which will be size based on the flow rate calculation that was used using Weymouth gas flow equation. For the subsea production wells, 8 wells will be grouped into 2 cluster manifolds, whereby the configuration will be containing 4 wells each. Then the subsea manifold would have 2 central manifolds collecting the natural gas from the wells through the flame and directly towards the processing facility. The pipeline end manifold, which is the flame, would be positioned at the well connections, each to handle 2 wells at the same time. Then we have the flet, which is the pipeline end termination, whereby it will be connecting to the flow lines and the riser systems. Then to the manifold through the jumper spool. Then we have the umbilical system, which provides power, control, and also chemical injection to the subsea structure through the subsea umbilical termination assembly. That's the SUTA and the subsea distribution unit. Lastly, for the time for first gas and the risk management plan. For the time for first gas, which is 5 years, we're expecting a pre-commissioning stage within 11 months, where we have the EPC of 36 months, and then the installation and commissioning taking 12 months, and also the first gas production to be approximately 1 month to 60 months. For the risk, uncertainty about the risk, about geological and reservoir risk. We'll be looking into the exploration and the development delays, operations and safety risk, the market price and philosophy. And in conclusion, to achieve a cost-effective field development of Scarborough gas field, IPS has developed a comprehensive risk assessment and mitigation plan to address potential challenges through the project's life cycle. The plan includes strategies for mitigating geological and reservoir risk, thereby development delays and operational risk, and also considering environmental risk along with other risks that will be involved in the project phase. Thank you very much.